Greetings and welcome, friends. Mr. Waddy here. It's a wonderful day. We're talking about algebra today. Algebraic expressions. Algebra, by the way, was it's a Middle Eastern word, Arabic. They had quite the Renaissance, I guess, maybe you'd call it. I don't know. They were discovering all sorts of math at one point back in the Middle Ages or something like that. But algebra was originally discovered as a means of distributing land amongst your offspring. I was going to say ancestors, but that doesn't make sense. You don't give land to dead people. That would be weird. But anyways, here we go. An algebraic expression, all right, different than a numerical expression, may contain numbers, like a numerical expression, operations. Let's see, Devin, what were the operations that we talked about yesterday? What do I mean by operations? You remember? Yeah. Yeah. And then we even talked about exponentiation and like roots as well, but you won't see those for a while. And one more symbol. One or more symbol. A symbol being a letter typically, which might be like lowercase a, it might be like capital B, it might be a Greek letter, theta, all sorts of things, but our symbols are going to typically be letters. And the parts of the algebraic expression are called terms. So when I say terms here, all right, check this out. A term would be like, in this example, 5p or 4. All right, each of those are terms, and this is a two-termed expression. All right, the symbol that represents one or more numbers is called a variable. So what this means is 5 times something plus 4, okay? And that's something we are going to be able to have it represent a variety of numbers. Maybe there's only one number that might make an expression or equation true in the future, but right now these are expressions. All right, so this is called a variable. The numerical factor of a term that contains a variable is a coefficient. All right, the coefficient is the number in front of the variable. The 5 is your coefficient here. And a term without a variable is called a constant. Regarding coefficients, while we're on that thought, here we go, coefficients. You guys might want to, you could fit this somewhere down next to yours. If I have 3x, if I have another expression, actually I'll just do this, 3x plus y minus 7z. Here we go. All right, if I want to talk about the coefficients, the coefficient of the 3x term, Devin, is the 3. All right, so that's the coefficient. What do you guys think the coefficient of this y is? 1. There's an invisible 1 hiding in front of that y like a hobbit wearing a ring. It was invisible the whole time, Cameron. The whole time. It was hiding in front of that y. What do you guys think the coefficient for the negative 7z would be? It actually will include the minus sign. So negative 7 is the coefficient there. All right, so that's just some coefficient concepts for you. Let's, oh dear, I just turned airplane mode on. I am not on an airplane. Although, that would be awkward for someone sitting next to me on an airplane as I'm recording math videos for internet friends. That'd be weird for them, I think. Here we go. Here's example 1. So you guys already have this. You're welcome. I wrote it down for you. It says, identify the terms. Okay, so let's do terms first. Let's see, what colors did I just have a moment ago? Oh man, that's too bad. Let's do terms in yellow. So my terms are 5x and 13 are terms. Okay, let's do coefficients in blue. Devin, write this down, Devin. I almost said Kevin. The coefficient is 5. Which is the constant? Yeah. So the constant would be 13 because it has no variable attached to it. And what's the variable? Is there a variable in this? Yeah, that would be just the x. Okay. How about over here? What are our terms for this part B? 2z squared. The square, the exponent, is still part of that coefficient. Another one, part of the term, my bad. Another term, what do you guys see, Cameron? What's another term in this? Y, and Cameron, last one? 3. So this has 3 terms, okay? Terms are going to be separated by plus or minus signs, is what we'll end up having. Cameron, I can't see. You're right in the way of my inkwell, friend. What is the coefficient of the z squared term, Jimmy? Jimmy. The coefficient will be just the number in front, so it's 2. And let's see, Pooja, what is the coefficient of this y term? What number? Yeah, there's an invisible 1 there. So the coefficients, Devin, don't do that. That actually grinds the gears of that. It wears it out and it breaks it as a tool. Thank you. So, and then the constant, is there a constant term on this, Devin? The 3. Yeah, and make sure you're writing this down, Devin, so that way it's part of your notes en su cuaderno. All right, so that's parts of the algebraic expressions. Let's see. Oh, man. I feel like this just jumped the gun. Did I? This even, what? Oh, right. Yeah. Okay. We talked about exponents, I think, some of us during an ACE block. But here we go. It says, write each expression using exponents. All right. What's another way of writing d times d times d times d? D to the 4th power. Perfect, perfect. And how about this? H times h times h is h to the 3rd. Does anyone know another way to say h to the 3rd? Sometimes that's called h cubed. Cubed, yeah. And so this would be 1.5 h cubed. So I would this would have a coefficient of I already forgot what colors I was using. 1, and this would have a coefficient of 1.5. All right, but each of those are their own term. Aha, here's this idea, evaluate. So with algebraic expressions, we've said that variables can represent numbers. And so to evaluate an algebraic expression, we are going to substitute a number in for each variable. All right, we're going to plug in a number for the variable and then use our old friend order of operations to simplify, to evaluate, to determine what the value is of the entire expression. So let's look at example 3 together. Example 3. Oh, where's my slider? Man, I'm so good at singing. I don't know why no one hasn't gone through all my YouTube videos and just pulled out the audio of whenever I sing and then combined it into some awesome dubstep video. You could do that. I release the rights of all my audio clips for that purpose. I'm fine with it. So let's see. This here's our algebraic expression. Question, how many terms does k plus 10 have? 2 terms, right? And they said evaluate when k is 25. So if k is 25, that means I can take 25 and plug it in for k. Right? And so instead of k, now I have 25, and 25 plus 10, well done, is 35. Right? So that's what it means when we substitute and evaluate. So evaluate 4 times n when n equals 12. I'm going to take 12 and plug it in for n. And I will end up having 4 times 12 is equal to 48. Yeah. El más rápido. 48. 48. All right, not bad, not bad. Ooh. How about this? I love this when math starts off easy and then they start combining all the skills you're learning like it's some sort of boss fight at the end of a video game level. It's amazing. Here we go. All right. What about if there's dos variables, mis amigos? A divided by B when A is 16 and B is 2/3. All right, this is scary for a couple of reasons. All right, I'm going to plug 16 in for what? What do you think I could plug? Just for the A. And then I can plug in 2/3 for the B. Right? I can't plug in 16 for B or vice versa, right? I plug it in only for the variable that it's equal to. So I'm going to have, 16 divided by 2/3. Guys, that is terrifying. You haven't seen something like that in my class, and it's probably been a year since you've seen something like that. Cameron, do you have a thought? If it was multiplying, it would. But dividing by a fraction, I don't know if you guys remember this trick. Yeah? All right, so Pooja is saying reverse. I think what she means is I can reciprocate. I can write the reciprocal, 3/2. A reciprocal is when I flip it. All right, so I'm doing two things. I'm flipping it, and I'm changing it instead of division to multiplication. I like that. So instead of dividing by a fraction, you can multiply by the reciprocal. Does that make sense? You guys, is that vaguely familiar? If that isn't, go check out some of my friend Khan Academy's videos. Sal Khan will help you out with multiplying and dividing fractions. Also, check this out. I could do now 16 over 1 if that helps. 16 times 3 and then divide by 2. But 16 times 3, that sounds like big numbers to me. So watch this. I can actually do 16 divided by 2 first. Did you know that? Watch this. This is called cross-canceling. All right. 16 and 2 are both divisible by what number? What goes into both 16 and 2? 2. All right. 2 goes into 2 once. And how many times does 2 fit into 16? 8 times, right? Man, you guys are good. You guys are good. And now that I've made those numbers smaller, now let's do the multiply. 8 times 3 is 24. 1 times 1 for my denominator is 1, but I don't need that 1 down there. 24 divided by 1 is 24, friends. 24. All right, let's do last one. Example 5. We are getting so good with the algebra. We're evaluating algebraic expressions. Man, this is so great. So let's do some substituting. Evaluate 3x minus 14 when x is 5. So what they're asking us to do is plug it in. Sometimes I call this plug and chug. You plug in the number and then you chug it out using the order of operations. So 3 times, instead of x, what's in there? 5. So, all right, order of operations, friends. Devin, what do I do first? Multiply or subtract? Multiply. Bam! He's fast. You saw that, friends. You saw that. 15 minus 14 is 1. I was going to say 1-teen, but that would be like 11. Not it. All right. Ooh, this next one's interessante. Plug in dos for my z. All right. So I'm going to have z squared is going to be 2 squared plus 8.5 decimales. All right, what do I do? Square or add first? Square, 2 squared. What does that even mean? Two times 2, right? Multiply by itself twice. 2 factors of 2. 2 squared is 4. And plus 8.5. 12.5. No calculator there. I like it. I like it. All right, thanks for watching, internet friends. Go evaluate some algebraic expressions. Bye.